All right, so here we've got the picture of the balloon, which is due north of an observer. So let's just think of it from looking above, like we're in a drone and we're looking down. So here's an observer, and it says a balloon is due north of an observer P. All right, so let's say the balloon's up here, due north. There's the balloon. Here's the observer at P. And then another observer Q, 100 meters from P. To them, the balloon is due west. So think about where they must be if the balloon is due west of them. So let's put Q over here because the balloon is due west, right? So that's west, whereas this is north. So you can see that this is going to be 90 degrees here in this base triangle. So if we put that over here, that angle, that B is the top where the balloon is. If I go straight down to the bottom, it's actually C. So that bottom triangle here is also 90 degrees. All right, so that's if we're looking straight down. So that actually is explaining why angle PCQ, which is this one, is 90 degrees. Okay, so if you're looking at from the top down, you can see it's 90 degrees. All right, so let's go back in this triangle and show that PC is HCOT 62. So we're interested in PC. So PC is this distance here. And you can see anyway, if you want the hints, we're using angle 62. So angle 62 degrees is in triangles. So you should say probably, so where you're looking. So I'm looking in triangle PBC. Right, I'm looking in this triangle. And in that triangle, you can see if I use tan 62, I'm going to get H on side PC. And if I make side PC the subject, I've now got H on tan 62. Or remember, 1 on tan, so the reciprocal of tan is cot. So that is the same as H cot 62. Yeah? So remember, 1 on tan theta is equal to cot theta. So third letter is tells you which reciprocal. Okay, so we know PC is H cot 62. We also know, if we have a look in the other triangles, if we have a look in this triangle here, so I'll say in triangle QBC, so the green triangle you can see, if I use the 55 degrees with tan, I'm going to get SOHCAHTOA, so opposite over adjacent, H on CQ, side CQ, and if I make side CQ the subject, again I've got H on tan 55, and so 1 on tan 55 is cot 55, so that's the same as H cot 55. Oops, that's not going to work, 55. So now we've got, if I go back to my triangle over here, which is PCQ, so my PC, so this side is H cot 62, and this side is H cot 55. So if we're interested in finding the distance PQ, so we are now looking in this triangle, so in triangle CPQ. And you can see it's a right angle triangle, so we can just use Pythagoras. So using Pythagoras here, I'll just move across a little bit. So if I'm using Pythagoras, you can see I need to square, I'll write it down, PC squared and QC squared should give me PQ squared. So that's Pythagoras theorem. So this being the hypotenuse, PQ being the hypotenuse. So remember PC we knew was H cot 62. So if we square that whole thing, it's the same as squaring the H. And for trig, we write the square there. So it's H squared cot squared 62. And if I square QC, H squared cot squared 55, sound notation. And if I square PQ, which we were told was 100, I get 100 squared. So now you can see I can factorize this side by h squared. They've both got an h squared in them. So if I factorize by h squared and make h squared the subject, I'm going to divide by that bracket, that cot squared 62 plus cot squared 55. So now just put that in your calculator and make sure you square root, and you should get something like this in your calculator. I'll put dot 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 there, and that is approximately equal to the nearest meter, 177 meters.